Let's work on problem 3.1.33. This is a good problem for reviewing supermesh and supernode. I'm going to work on this problem using nodal analysis first and then using mesh analysis as well. Let's use the nodal analysis. If you want to use nodal analysis, we need to identify nodes. So the first node is right here. It's going to be -6 because the negative terminal at the top. And then there is a node right here. I'm going to call this is a Vx because Ix going downward. And we're going to call this as a Vy. And finally, we're going to call this as a V0. So the problem asks us to find the V0. First, we need to assign the direction of the current. So I'm going to just go from left to the right. Top to bottom is already there. I of x is the same one. This 2 milli, we don't have any choice but going upward, and then we have going here and going down there. So we assigned all the direction of current. Now by looking at this, there is a dependent voltage source between two nodes Vx and Vy. Therefore, we need to do supernode. Supernode is gonna be this. So this is supernode. First KCL at supernode, entering -6 minus Vx over 12K. There's one more entering the 2 milliamps plus 2 milli, and then leaving from Vx over 4K plus Vy minus V0 over 2K. So if we multiply everywhere by 12K, we're gonna have -6 minus Vx plus 24 equals 3Vx plus 6Vy minus 6V0. And if you simplify a little bit, we end up getting 18 equals 4Vx plus 6Vy and minus 6V0. That's our first equation. Now, since we use supernode, we need to do KVL including supernode. So KVL at supernode, that is -Vx -2Ki of x plus Vy equals to 0. Since we let Vx at the top, we have here's a Vx minus, right? So that's what happened with this Vx, the first term with the negative. Now, the first equation we have in terms of Vx, Vy, and V0. For the second equation, we have I of x. So we need to find I of x to replace in terms of Vx, Vy, or V0. By looking at the Ix right here, Ix is gonna be Vx over 4K. V goes to IR, I goes to V over R. Now we can plug this into this equation. Then we have -Vx minus 1 over 2 Vx plus Vy equals to 0. And then we have -3 over 2 Vx plus Vy equals to 0. That's our second equation. And the third equation, we need to do KCL at V0. Then we have entering Vy minus V0 over 2K equals leaving V0 over 4K. If you multiply by 4K, and we have 2Vy minus 2Vo equals to Vo. Move it over, we have 2Vy minus 3Vo equals to 0. That is our third equation. So using 1, 2, and 3, we should be able to find Vx as 18 over 7, Vy equals 27 over 7, V0 equals to 18 over 7. That is our answer. Use the same circuit. Let's apply mesh analysis. So we need to do is we have to assign the mesh current first. So I'm going to call it this as I sub 1, and this as I sub 2, and this as I sub 3. Again, mesh current, that is not going through in the middle registers. Okay, so I1 in this case goes through 12K ohm resistor, but not 4K. You have to be careful with that. Let's do KVL using I1. Positive 6 plus 12K plus 4K. Our reference current is I1. So I1 minus I2 equals to 0. So from here, you can have 16K I sub 1 minus 4K I sub 2 equals to negative 6. That's our first equation. Second equation, we have I sub 2, but we have independent current source 2 milliamp going up, and that current source is between two mesh current. So we have to use super mesh. So KVL at super mesh, we have 4K I sub 2 minus I sub 1. Why I sub 2 minus I1? Because I sub 2 is the same direction as a super mesh. So in the 4K, we have I sub 2 going from bottom up, but I sub 1 is top to bottom. So we have to say 4K times I2 minus I1. Next, minus 2K I sub x plus 2K I sub 3 plus 4K I sub 3 equals to 0. The first equation, we have I sub 1 and I sub 2. We want to make all these in terms of I sub 1, I sub 2, and I sub 3. However, we have I sub x. So we need to find the relationship between I sub x with other mesh currents. If you look at the bottom of this I sub x, we can do KCL at A, I sub 2 at the bottom, entering, and I sub 1 is leaving. So entering I sub x plus I sub 2, leaving I sub 1. Therefore, I sub x equals I sub 1 minus I sub 2. We can plug this into here. If we do, we're gonna have negative 4K I sub 1 plus 4K I sub 2 plus 6K I sub 3 minus 2K I sub 1 minus I sub 2 equals to 0. If you simplify combining same terms together, negative 6K I sub 1 plus 6K I sub 2 plus 6K I sub 3 equals to 0. And that's our second equation. Our third equation should be using 2 milliamp because we make this as a super mesh. We haven't used this 2 milliamp current source at all. So what we can do KCL again at B. KCL at B, we have I sub 3 going in, I sub 2 is leaving, and 2 milli is leaving. So entering I sub 3 equals leaving I sub 2 plus 2m, and that is I sub 2 minus I sub 3 equals negative 2 milli. That's our equation number 3. Now you can use your calculator, type all those in, but you need to be careful because first two equations, we have a 16K, 4K, 6K, but the third equation, we have no K. Make sure you have consistent notation. You don't want to mix up with the negative 2. So when you type all these coefficients in your calculator, you use 16s and minus 4, negative 6, and the third equation, suddenly you type 1, negative 1, and negative 2, you end up getting different answer. So what we can do for the first equation, you divide everything by K. So 16 I sub 1 minus 4 I sub 2 equals to negative 0.006. And the second equation, we have negative I sub 1 plus I sub 2 plus I sub 3 equals to 0. And then third equation, I sub 2 minus I sub 3 equals negative 0.002. So using these three equations, you have I sub 1 equals negative 1400, I sub 2 equals negative 1.357 milli, and I sub 3 equals to 0.643 milli. V naught is 4K times I sub 3. V naught equals 4K times I sub 3 and 4K times 0.643 milli. That will give us 2.57 volts.